Hello friends, welcome to my channel. Let's have a look at problem 2369. Check if there is a valid partition for the array. So in this video, we're going to share a solution using dynamic programming. So first, let's look at the statement of the problem to digest the requirements. So we are given a zero-indexed integer array called nums. So we have to partition the array into one or more contiguous subarrays. So below are the three rules to form subarrays. So either we have two equal elements, or we have three equal elements, or we have a arithmetic progression with increment 1, for example 3, 4, 5. So those are the three rules. So we are required to return true if the array has at least one valid partition, otherwise return false. So let's look at the examples. So in example 1, so we can consider the first two elements 4, 4 to form a two equal element group, and 4, 5, 6 to form an arithmetic progression with increment by 1. So the return is true. And in example 2, so we have 1, 2 here, so but we do not have 0 in the left. Therefore, the return is false. So before we do the analysis, let's look at the constraints on the problem here. So the nums has length at least 2 and at most 10 to the power 5. So 10 to the power 5 actually is a decent large number. So for sure we cannot solve this problem using pure brute force. So the second item actually is on the range of elements in the nums array. So with that said, so we are ready to do the analysis. So when it comes to dynamic programming, so we can consider using cache and writing in a recursion format, or we can use tabulation. So here we are going to take the second way. So in this way, so the interpretation and the DP update rule are the two main ingredients. First, we'll interpret DPI to be if there exists a valid partition for the nums array starting from index 0 and ending at index I. Let me emphasize that here index I included. So with that said, let's consider the DP update rule. So here we only do the update when necessary, and also we want to know how to update, right? So actually we need to check at most DPI minus 2 and DPI minus 3 based on the relations between the three numbers nums I minus 1 and nums I minus 2. So let's look at the two items below, and hopefully it will make it crystal clear about the update rule. So first, if nums I equals nums I minus 1. So in this case, actually we can consider put nums I and nums I minus 1 together as a two equal group. So and also we can consider if nums I minus 1 equals nums I minus 2, then in this case, so DPI is true if one of DPI minus 2 or DPI minus 3 is true, right? So meaning that we could consider two equal group, or we can consider three equal group, right? But if this condition does not satisfied, we just need to consider if DPI minus 2 is true. So here actually we need to consider a special case. So if I equals 2, in other words, we do not have I minus 3. And in this case, if we have nums I equals nums I minus 1 and nums I minus 1 equals nums I minus 2, in this case it corresponds to a nums array like say 1, 1, 1, right? In this case we should set DPI equals true. So this is an important edge case. So the second item is that if nums I does not equals nums I minus 1. So in this case, we only do the update for DPI if nums I minus nums I minus 1 equals nums I minus 1 minus nums I minus 2 and equals 1. In other words, the three numbers from left and ending at index I actually forms an arithmetic progression with increment by 1. So in this case, what we hope is that we set dpi equals dpi minus 3 if I minus 3 is greater than or equal to 0. Otherwise, we need to make it true, right? Because it's corresponding to, say, a length 3 nums array, like 3, 4, 5, right? So we do not have I minus 3. So with that said, I guess we can write the code very straightforward. In a very straightforward fashion, I would say. First, let's make some preparation. So we're going to track the length of nums, and also we want to initialize the dp table. So we're going to dp equals dp 0 times n. So 0 represents false and 1 represents true. So then we're going to set dp1 first. So dp1 is the second element, so we can only consider length 2 group, right? So it equals if nums1 equals nums0. If so, it forms a valid partition, otherwise not. So this is the first step. The second step is the main update loop. So for this, basically it's a for loop for I in range 2 to m. And then first, let's consider the case if nums I equals nums I minus 1, right? At this stage, actually, we can consider set dpi to be dp I minus 2, because I is always no less than 2, right? So then we need to consider one more step, right? So let's write it in another format so that we can make this very clear. So I'll write a if and else. So that's maybe better, right? So if nums I minus 1 also equals nums I minus 2. So in other words, we have the three numbers at index I minus 1, and I minus 2 are equal. So we can consider group 2 group or 3 group, right, with equal elements. So in this case, first let me set dpi equals dpi minus 2, right? So then we want to distinguish if I minus 3 is valid index. If this is the case, we're going to update this dpi to be the integer. So dpi, because we have already set it as dpi minus 2, right? So this is or dpi minus 3, right? If one of these two is okay, then dpi should be true. So then actually another thing we want to consider is that, so if I minus 3 is less than 0, so in other words, the length is 3. So in this case, we're going to set I equals 1. So this corresponds to, say, a length 3 case, right? So this is the edge case. So this is actually the first block. So and then we want to consider another case. So else. So if nums I minus 1 does not equals to nums I minus 2, so in this case we could only set dpi equals dpi minus 2. In other words, if dpi minus 2 is true, dpi will be true. So then let's consider the else. So in other words, in this case we consider nums I does not equals to nums I minus 1. Then we are only update when nums I minus 1 and nums I minus 2 has a gap 1, right? So if nums I minus nums I minus 1 equals 1, and then we consider the sub case I minus 2, let's see, equals 1. So in this case, we are going to consider if I minus 3 is greater than or equal to 0. So we're going to set dpi equals dpi minus 3. In other case, if I minus 3 is less than 0. In other words, we are facing a length 3 case. So we are going to set dpi equals 1. So this else block actually is parallel to this else block. So this is actually very important. So here is a case corresponding to a plus 1, a plus 2. It's also an edge case corresponding to length 3. So this way of writing the main update loop is a little bit messy, right? So we can for sure shrink the length, but the logic is clear, we feel. And then third, so we're going to do the return. So the return is nothing but dp -1, right, according to the interpretation. So now we are ready to do the check. So first, let's check a special case. Yeah, it passes the first example, I guess. So now let's do a generic case check. Yeah, it passes all the generic cases. So I guess with this solution finished, that's about it for this video. But you are welcome to actually do something further. For example, write the solution in a recursion format using cache, right? So yeah, that's about it. Thank you.